Hi, welcome to this video on the calculations of the isoelectric points of tyrosine and histidine. So isoelectric point is a characteristic feature of amino acid as well as protein. This is the pH at which an amino acid carries a net zero charge. This form of amino acid is known as deuterion. Deuterion has both positive and negative charges in equal amount. That is why it has net zero charge. We will learn today how to calculate the pI of tyrosine and histidine. To calculate isoelectric pH of an amino acid, for example histidine and tyrosine, you should have three pieces of information available. The first one is you should be able to identify ionizable group. For example, in these cases you have three ionizable group. The first one is carboxylic group, second is amino group, and the third one is the the side chain, which is phenolic group in tyrosine and imidazole is in histidine. And the second thing is you should know the characteristic pKa value of each group. For example, carboxylic group has pKa corresponding to 2. Amino group has the side chain has pKa will depend on the type of the R group. For example, in histidine it is pKa is 6 and in case of tyrosine the pKa is 11, and amino group has pKa in the range of 9 to 10. So this piece of information you should know, and also you should be able to know how the charge on this molecule will be affected by changing pH around their pK values. Once you know that three pK values, you have to do three things, or you have to follow three steps. First is to identify the deuterion for each amino acid. For histidine, this is the deuterion because there is net zero charge on this molecule, and this is for the tyrosine deuterion. For tyrosine, it also has net zero charge. Now the second thing you have to identify is the pK values flanking the deuterion. So there are two pK values which are flanking the deuterion formation, and you will notice that deuterion is for midway between these two values. Therefore, the third thing you have to do, you have to average the values of these two pK values flanking the deuterion to calculate the pI. So let us begin to calculate the isoelectric point of histidine. The first thing to know is that there are three ionizable group in this molecule. The first one is carboxylic group, which has pKa close to 2. Second is the imidazole group, which has pKa equal to 6. And the third one is alpha amino group, which has pKa 9.2. These values must be known in order to identify the generation of the deuterion as well as the flanking pK values, so that we can calculate the isoelectric point of this amino acid. So let us see how the charge on the histidine is changed by changing the pH around these three pK values. So this is the pK2, 6 and 9.2, as I have already shown you in the previous slides. If you change the pH around these pK values, there will be change in the charge on the molecule, and at some point there will be formation of deuterion. So we have to identify where the deuterion is formed and what are those two pK values flanking that deuterion. So if you decrease the pH below 2, you will protonate this molecule. This is the histidine, so this is fully protonated. The net charge on this molecule is plus 2. When you increase the pH beyond 2, you will deprotonate the carboxylic group, leading to the formation of this moiety. This has plus 1 charge, and if you go beyond pH 6, the imidazole group will be deprotonated, leading to formation of this ion. This has both positive and negative charge in equal amount, therefore the net charge is 0. If you go further beyond 9.2, then this will be deprotonated again, leading to the formation of this ion which has net 1 negative charge. So on your left hand side you have the fully protonated, on your right hand side you have fully deprotonated, and in between you have this zwitter ion which carries 0 net charge. So you identify that this is being formed in between pK2 and pK3, right? So what will be the pi for this? You just average these two values. So this is the formula: pi is equal to pK2 plus pK3 divided by 2, which comes out to be 6 plus 9.2 divided by 2 is equal to 7.6. So this is how you will calculate the pH of histidine. So why histidine has been selected here? Histidine is a very important amino acid, because this is the only amino acid which has buffering capacity as physiological pH, and in many examples you cannot miss out. You will see some questions on histidine for sure. The other point to note is that if you decrease the pH, if the pH is less than pi, the molecule will carry positive charge. If the pH is higher than pi, the molecule will carry negative charge. So keep this in mind also. So now let us calculate the pi of tyrosine. This is the tyrosine here. In the tyrosine also you have three ionizable group. The first one is carboxylic group with pKa is equal to 2. The second one is alpha amino group which has pKa close to 9, and the third one is the phenolic group which has pKa close to 11. So these three values must be remembered or must be known to you to calculate the pi of this molecule tyrosine. Tyrosine also is important in the sense that the pKa for phenolic group is well above the physiological point. So under normal physiological condition it will not contribute to the formation of the zwitter ion. So let us calculate the pi of tyrosine. You have known that there are three pK values, 2, 9 and 11 for this amino acid. So we let us see how the charge on the molecule will change by when we change the pH around these 3 points. So if you decrease the pH below 2, the molecule will be fully protonated, which carries plus 1 charge. This is also called as multiprotic amino acid because there are three groups which can donate proton. If you increase the pH beyond 2, carboxylic group will be deprotonated and you will see formation of this species which has zero net charge. It has zero net charge because plus and negative charges are in equal amount. So this is the zwitter ion. If you increase the pH beyond 9, amino group will be deprotonated and you will make this ion which has minus 1 net charge. If you increase the pH beyond 11, the phenolic group will ionize and you will make this ion here which has minus 2 net charge. So on your leftmost you have fully protonated form, on your right hand side you have fully deprotonated form, and you have make zwitter ion midway of pK1 and pK2. So you can simply calculate by averaging these two values using this formula: pi is equal to pK plus pK2 divided by 2, which comes out to be 5.5. So if you are given the pK values and you know or you have mastered the formation of the zwitter ion, you can easily calculate pi of a given amino acid. So thank you very much for watching this video, and I'm sure that with practice you will be able to calculate the pi of a given amino acid. Please like it, subscribe it and share with your friends. It will not cost you anything. It will encourage us to post more videos on biochemistry topics. So until next time, you take care and bye bye.